Alright, today's lesson is a continuation of 2.5 that used properties of Algebra 1. So yesterday we worked on solving and stating reasons and steps for our solving procedures. Today we're talking about more mathematical properties that you learned in Algebra 1, but today we're applying them to geometry. So the first thing we need to discuss are these three properties that I circle. Please circle these three properties. And let's go ahead and number them. 1, 2, 3. These are the three properties we are discussing today. The first one is reflexive, number 2 is symmetric, and the third is transitive. In case you've forgotten, the reflexive property states that for any real number A equals A. Pretty simple. It doesn't really help us a lot in math. You don't see this one used a whole lot. For the segment length, it'll say for any segment AB is equal to AB. What do you think the third one's going to say? For any angle A, measure of angle A equals measure of angle A. Remember, if we are going to say angles are equal, we have to say the measure, the actual numbers. So basically, what's going on in that property? What's a little phrase or something I could say to remind myself what the reflexive property actually does? Mirrors itself? Okay, I don't like that word because some people confuse that with symmetric. It's a good idea though. What I like to write is it equals itself. It equals itself. A equals itself. It equals itself each time. The term equals itself. Not very complex. Number 2, symmetric property. For real numbers, A and B, if A equals B, then B equals A. Good job. Alright, we can also apply that to segment length. So AB equals CD, we can say CD equals AB. Alright, the third one, dealing with angle measures. It says measure of angle A equals measure of angle B. What can we say? Correct. Measure of angle B equals measure of angle A. Good job. What's a little phrase that we could write out to the side for that one? I wouldn't exactly say mirror. People confuse mirrors. I don't like using the mirror. Opposite. Okay. Here's a simpler word that last class came up with. You switch them. You switch them. I'm not spelling correctly. Switch. Or some people say flip. You switch them or flip them. Keynote, they do not change the order. So if it says AB, we don't change it to BA over here. It stays the same order. You might want to make that note out to the side. The letters or the segment lengths will stay in the same order. Transitive property I like because it connects back to some stuff we've been doing with our laws of logic. I like this one a lot. Let's see. It says for any real numbers A, B, and C, if A equals B and B equals C, then, I heard it, A equals C. How do they get that? Okay. There's no addition, so it's not exactly part plus part equals whole. It is like the law of syllogism, in which we cut the repeats and write the leftover. That's exactly what's going on. We cut these repeated parts and we wrote the leftover. So what's it going to be for segment length? Yeah, we cut out the repeated parts and we write what's left. AB equals EF. For the angles, what should we say? Measure of angle A equals measure of angle C. Once again, what have we been doing in those three examples? What's the phrase that I can write out that reminds me what to do? cut the repeats, and write the leftovers. Perfect. Cut the repeats. And write the leftovers. And once again, it's very similar to the law of syllogism. Very similar. What's the difference between this stuff and the law of syllogism?
Syllogism is if and then.
Syllogism has a bunch of if-thens. There are no if-thens really. There kind of is. This is kind of a conditional. So maybe like one if-then. But definitely not three if-thens like we're used to seeing in syllogism. Good job. Let's look at the next little part. It's a little example. And this one's kind of tricky. This is actually the first geometric proof that we're doing this year. We've done some algebraic proofs in which we showed the math steps and we stated reasons for each step. Those are algebraic proofs. This one right here is our first geometric proof. And I wish they wouldn't have started this hard. This one has a lot more steps than I would have liked to see, but it has some really good content, and you know, you have seen all of these reasons that we'll be using. It's just applying it to this geometric situation. What we're going to start off first is we're going to read the question. It says, show that CF equals AD. That is our goal. And usually when you're trying to prove something, that will be your last little statement. CF equals AD. So I can go ahead. I know that's going to be my last step. That's what I'm trying to prove. But I have to fill in a lot of blanks to get down to that step. Did they give us any other given information up here in the question? What did they give us? Oh, they gave us stuff in the picture. So you're referring to stuff in the picture. He saw that AB is equal to EF. So we can write that down. That is a given statement from the picture. What other given information can you pull from the picture? BC has the double, and DE has the double tick marks. So that is BC is equal to DE. All right, most everybody's good with those two. You pull it from the picture. You write givens because it gave you those things. But then you see something that has AC equals AB plus BC. Huh, that's interesting. Let's see where that comes from in the picture. So it comes from the total AC being broken down into AB plus BC. What does that remind you of? Part plus part equals whole is a good response, yeah. But what was the postulate, the real postulate name for part plus part equals whole? Segment? Yeah, segment addition postulate. We're going to use this one a bunch this year. Segment addition postulate. And remember, postulate. Remember, that one was part plus part equals whole. Up next, we're going to look at the next little statement here. It starts with DF, and DF is broken down into two parts added together. If we look at that in the picture, DF is broken down into what two pieces? DE and EF. DE plus EF. That's a good response. So the next step they give us, DF equals BC plus AB. Now, these two pieces are very similar to each other, so let's look at what changed. It changed some things in this little segment addition postulate. How do you change DE to BC, or why can you do that? Because they're the same size. They are equal to each other, and that is stated right up here. BC is equal to DE. That means that we can replace them with each other. And what is the property for replacing? Substitution means replacing. Same thing for EF to AB. I can change them out. I can replace them with one another because they're equal to each other. Anytime I see an EF, I could plug in AB, and that's exactly what they've done. On the next step, they write df equals something. A lot of people can see in the picture that df right here is going to be the same size as AC, and that is correct. But what's the math reason for that? Okay, we know it's substitution, not by looking at the picture though. We know it's substitution because we see that df equals this, and this is repeated up here. So anywhere I see this, I could plug in AC. So I can plug it in right there. That is the key fact of substitution. Anywhere I see this, I could plug in AC, or I could plug in df, because they are the same piece. That is substitution. The last step. Now we have to look at this next step. How do we go from here to here? So a lot of people can look in the picture and see that df plus cd, and I'll highlight that real quick. df plus cd is the same as saying something plus cd. And a lot of people say, oh yeah, it's AC. And I get that. A lot of people get that, but they miss the math reason. What's the property or the reason for stating that? Well, yeah, going from here to here, we're just adding CD to each side. So addition property of equality. Some people will put substitution. I'll give you some credit for that, but it's really adding CD to each side. The last step. Why are we able to go from here to here? We got to look at that carefully. Once again, we look at these statements and compare it to the picture. They say df plus cd, and we can see that df plus cd is the same as AC plus cd. Yes, that's true. But how long is df plus cd? The total length is cf. That's where it comes from. And how long is this total length from A to D? When we put them together, it is AD. So really they're adding that piece to each side. So sometimes it would be acceptable to switch those. And the more of these we do, the better it'll get. I would be okay if you switch those, just get out of order a little bit. You'd just lose a little bit of points. But that's a very, very good problem. Obviously it's a little hard for the first proof that we've ever done. The last thing we're doing is we're going over these 4 checkpoints. So I'm going to give you a little time. Try these on your own. This first one says, take this little equation and solve it for S. Solve for S. And write a reason for each step. These next ones, 4 through 6, they say, name the property of equality. What are some of those properties of equality that we did earlier? We did substitution. What else? Addition. Addition, subtraction, division. I like those. These are the ones we'll be using. Symmetric, reflexive, transitive. So I'm just kind of giving you a word bank. I want you to list out the whole property though. The whole property on each of these. I'll give you a little bit of time. Go ahead. On number 3, it says, suppose the equation, example 3, is d equals 5, parentheses, s plus 3, close parentheses. Solve for s. First step, you always write the equation down. You write the given equation down. So I basically just said the answer. They gave us this equation. That is our property. Also remember, anytime you see an equals, you will be writing a property, a reason. First step, whenever you're trying to get rid of a number outside parentheses, what do? You distribute. Everybody should recognize that property. It's used all the time. So 5s plus 5 times 3, 15. What property did we do right there? Distributive, and write it out. Some people stop there. That's not enough. At least write distributive property. Definitely it is of equality. Next, I'm trying to get S alone, so I got to get rid of the 5 and the 15, meaning I need to move them to the other side. Which term should I move to the other side first? I move the 15 first because it's already separated from the s, and it's easy to move just a plain number. So subtract 15 from each side. I'll write it real small. So now it's d minus 15 equals 5s. What property did we just do to get to here? Subtraction property of equality. Last step. What do we do now? Divide by 5 on each side. So it's going to look like this. D minus 15 divided by 5 equals s. And remember that whole top piece is divided by s. So I put parentheses around it just to clarify. What property did we do? We did the division property of equality. Some people will go one step further, and we've talked about this already. They'll just write d over 5 minus negative 15 divided by 5 is 3 equals s. How did I do that, though? To go from here to here, what property did I just do? Did I divide on each side? No, I didn't divide on each side. I simplified. When you don't do something on both sides, you can't say that property. This is just a basic simplify. That would be cool too. I would accept either of those answers. They're both really good. Any questions there? All right. So the next part, and try to ignore the green writing. I'm just going to read the question. If GH equals JK, then JK equals GH. Which of these properties right here is going on? That is the what property? Oh, if you remember, RST 1, 2, 3. And the numbers were how many whats? Equal symbols. If you don't remember that, you're going to struggle with these easy ones. How many equal symbols did we have on number 4? 1, 2. 2 is S, and S is symmetric property of equality. Next one has 1, 2, 3, and remember they are cutting the repeats and writing what's left. That is the transitive property of equality. The last one, how many equal signs? Just one. It equals itself. That is the reflexive. And make sure to write property of equality, especially on these simple ones. That's not asking much. Good job.